common design requirement is that an environment must fit the range of people who fall between the 5th percentile for women and the 95th percentile for men. In designing an assembly work table, the sitting knee height must be considered, which is the distance from the bottom of the feet to the top of the knee. Males have sitting knee heights that are randomly distributed with a mean of 22.5 inches and a standard deviation of 1.2 inches. Females have sitting knee heights that are normally distributed with a mean of 19.8 inches and a standard deviation of 1.1 inches. Use this information to answer the following questions. What is the minimum table clearance required to satisfy the requirement of fitting 95% of men? First, to find the minimum table clearance required to satisfy the requirement of fitting 95% of men, determine the value of z that corresponds to 95%. We want to sketch and shade the region in the graph to the left of 0.95. And then we're going to determine the z-score that corresponds to the area to the left of 0.95 and then rounding it to 3 decimal places. So let's go ahead and then draw our bell curve and then label the items that we need to label. So we know that the mean for men here, males has a mean of 22.5 inches. So therefore this is 22.5 inches. Okay, and we want to shade 95% to the left. So therefore this is going to represent 95% to the left, and then we're looking for the value of x. So let's go ahead and shade the area that's to the left, since that is what we're looking for. So it's not what we're looking for. We're actually given the area. What we're looking for is the value of x. So therefore, we know that the area here to the left is 0.95 or 9500. Now, again, x represents the inches. So this represents the inches, and this is for males. So this is for males because we're using the mean of 22.5. So we want to now put in the z-scale. Now the z-scale is going to have a mean of 0, and we also want to find first what is the z-score that is associated with the value of that x. So what we're going to do now is open up StatCrunch. So if we open up StatCrunch, if you already had something else before, my recommendation is always select refresh so you can start over. Okay? So now what you're going to do is you're going to make sure that you have the mean of 0 and a standard deviation of 1. We want to make sure that you're going to the left because you want the area to the left. And then in the area section, we're going to put in 0.95 and determine what that z-score is. So we're going to go ahead and copy that, and there's our z-score. And again, they want us to round that z-score to 3 decimal places. So if we round that to 3 decimal places, then this z-score ends up being 1.645. So we get 1.645 for the z-score that's associated with the value of x. So now that we found that z-score, now to obtain the corresponding x value, we substitute the mean of 22.5, the z-score that we found to be 1.645, and the standard deviation of 1.2 into the formula. So let's go ahead and do that. So we know that the value of the mean is 22.5, and then we're going to add the z-score, which is 1.645, and multiplying it by the standard deviation of 1.2. So if we take 1.2, multiply it by 1.645, and then add 22.5, we get 24.474, and rounding it to 1 decimal place gives us 24.5. So therefore, we can come back up here and then write out that this equals, so x is equal to 24.5. We want to check to verify that that's greater than the mean, which is 22.5, which it is. So therefore, the minimum table clearance required to satisfy the requirement of fitting 95% of men is 24.5 inches. Also, if there is a clearance of 95% of males, there will certainly be clearance for all women in the bottom 5%. Now, determine if the following statement is true or false. And if there is a clearance for 95% of males, then there will certainly be clearance for all women in the bottom 5%. Well, the mean sitting knee heights are the 50th percentile values, which means that the values equal to the mean for men will provide clearance of 50% of men, and values equal to the mean for women will provide clearance for 50% of women. So the statement is true because the 95th percentile for men is greater than the 5th percentile for women. Now, the author is writing this exercise at a table with the clearance of 24.3 inches above the floor. What percentage of men fit this table? Now, to find the percentage of men that fit at a table with the clearance of 24.3 inches above the floor, we want to sketch the graph and shade to the left of 24.3 inches because we want to figure out what is the percentage of men that can fit 24.3 inches. So what we're going to do is we're going to draw our bell curve. So let's go ahead and draw our bell curve and then label all the items. So we know that our mean, and again we're dealing with the percentage of men, so the mean is 22.5 inches. Okay, and so we know that X is going to represent inches. And again, we're looking at the bell curve for men since we're dealing with the 22.5 mean. So now we know that 24.3 is going to be to the right of that value. So that tells us that X is going to equal 24.3. And again, we want to shade the area that's to the left. So we're going to shade the area because we want to figure out what is the percentage of all the men that can fit this 24.3 inches. So we're looking for the area here that's to the left. Okay, so the area again represents a probability. Now, in order for us to do this, we're going to have to convert this to our z-score. So we're going to go ahead and write our z-scale. And we know that our mean for our z is 0. And then we want to find out what is the value of z according to our x value of 24.3. So to convert the normal random variable x to the standard normal random variable z, using the formula below, where we're given the mean and the standard deviation. So we want to find the corresponding z-score when our value x is 24.3, our mean is 22.5, and our standard deviation is 1.2. So we're going to plug it into our formula. So the mean, well, first x, the data value is 24.3. We know that the mean is 22.5 and the standard deviation is 1.2. So if we go ahead and then put that into our calculation, we would take 24.3, subtract 22.5 and divide by 1.2, and we get a z-score of 1.50. So we would then say that the z-score corresponding to x equals 24.3 is 1.50. So what we want to do is we want to find the area to the left of 1.5 in standard normal distribution with a mean of 0 and a standard deviation of 1. So we're going to open this up in a StatCrunch. We're going to go ahead and go to options and then select refresh. Okay, and we want the mean to be 0 and the standard deviation to be 1. We want it to be to the left, so we want the error to point left, which is less than or equal to, and we're going to put in the z-score of 1.50. And therefore, it's going to give us our area, or also probability. So let's go ahead and take a look at that. So we get the area here of, rounded to 4 decimal places, 0.9332. So this is 0.9332, which represents the area to the left. So we know the area to the left is 0.9332. If we multiply this by 100%, then we would get 93.32% of men fit at a table with a clearance of 24.3 inches above the floor. Now, what percentage of women fit this table? So we're going to repeat this procedure to find the percentage of women that fit the table at a table with a clearance of 24.3 inches above the floor. So now we're going to go ahead and then again draw our bell curve. But now we need to determine what is the mean for women. So we have to come back up to the question up here, and you can see that the mean for women here is 19.8 inches with a standard deviation of 1.1. So that means here we're going to have 19.8 inches. Okay, we know that X is going to represent inches. And now this is for women. And again, using the same amount, we're going to have 24.3. So here, X is equal to 24.3. And again, we want to find the area that's shaded to the left. So we're going to go ahead and find that area. Okay, and just like the process that we've done before, we're looking for the area. Now we need to also then convert that X to a z-score, so we need to use our z-scale. And remember that the z-scale has a mean of 0, and we're going to look for z. So we're going to find the corresponding z-score when the mean is 24.3, when X is 24.3, the mean for women is 19.8, and the standard deviation is 1.1. And then we're going to round our result to 2 decimal places. So plugging it into our z formula, we know that X is 24.3. We know that our mean is 19.8. And we know that our standard deviation is 1.1. So if we take that value of 24.3, subtract 19.8, and divide by 1.1, we get 4.090909. Rounding it to 2 decimal places gives us 4.09. So that is our z-score. So the z-score corresponding to X equals 24.3 for women is 4.09. Now we want to do is find the area to the left of 4.09 in a standard normal distribution with a mean of 0 and a standard deviation of 1. So we're going to open this up in a StatCrunch, come up here to Options, select Refresh, make sure we have a mean of 0 and a standard deviation of 1. And now we're going to put in the z-score, which is 4.09, and that's going to give us that area or probability. So let's go ahead and do that. So we end up getting the following. We have 0.99997, and we want to be able to round that to 4 decimal places. Okay, so if we round it to 4 decimal places, that means we got to round this up to 1, then this becomes a 0, this becomes a 0, this becomes a 0, and this becomes a 1. So we end up getting 1.000. So therefore that represents our probability or percent. So the area to the left of z equals 4.09 is 1.0000, and then if we multiply this by 100%, then therefore we would say 100% of women fit at a table with a clearance of 24.3 inches above the floor. Now, does the table appear to be made to fit almost everyone? Well, since 93.32% of men fit at a table with a clearance of 24.3 inches above the floor, and 100% of women fit at the table will fit almost everyone except about 7% of the men with the largest sitting knee heights. And how do we get 7%? That's because if we take our 100% that we found for women and then we subtract the 93.32, we get approximately 6.68, which is about 7%, and that's how we're getting the value of 7%.